Hi, what we're going to do in this tutorial is look and see if we can find the x-intercepts using something called the Null Factor Law, which you should have seen before. We'll remind you how it works though. Here's the first of our three examples. To find x-intercepts occur when y equals 0. So I'm going to replace the y with 0 and I will list that there. Now the null factor law comes in and it says if we multiply two things, this first bracket by this second bracket, and the result is 0, then either the first bracket equals 0, so x plus 3 equals 0, or possibly the second bracket was equal to 0. And we can quote what's called the NFL or null factor law to support us in that. If x plus 3 equals 0, it follows using methods of backtracking that x would equal negative 3. However, if x minus 2 is equal to 0, it follows, again using backtracking, that x would equal 2. So now we've got the two possible x-intercepts. To follow on here, we're going to look and see if we can find the y-intercept. So our y-intercept here, and that occurs when x equals 0. Can be found by just substituting 0 in place of x. So in this bracket, the first bracket, we'll evaluate to 3 and the second to negative 2, which when you multiply gives us that. So our x-intercepts are equal to negative 3 and 2, and our y-intercept, and we'll only have one of those, will be negative 6. Continuing on to our second example, in this one our equation is not factorized, so our first thing that we need to do is actually factorize it. And you'll recall using the who am I method or some other method that this can be done in this form. Having done that, the steps are identical to the first example, so I'll go through those. Using the null factor law, either x plus 4 equals 0 or x minus 2 equals 0. And now finding the y-intercept. Oops. So summarizing those results, we've again got two x-intercepts. We don't always need to have two intercepts. 2 is our maximum. We can sometimes have just one, and on odd occasions we don't have any at all. So that's that one completed. Moving on to our third and final example. This one is not a trinomial so much as a difference of perfect squares. You might recall with difference of perfect squares that in fact when we factorize them, which is the important first step, it'll be done in this form. And then once we've factorized, the process is identical to what we've seen before, finding the x-intercepts firstly by letting y equal 0. So therefore x will equal 3 or negative 3. And our y-intercept Now I'm going to go back here and just use the original form of the equation, which was x squared minus 9. It's much easier. So 0 take 9. And there's our intercept. You might recall from previous work that if we've got it in that form, the y-intercept is simply the constant term, in this case negative 9. And we're done. Thanks very much for watching.